Hi again. So in this lesson, we're going to be trying to find the vertex of a parabola, when it's given in standard form. And I'm going to do this in two different ways. I'm going to first do it the way that the book teaches you, and you might have to do this a couple times on your homework. And then I'm going to give you the form. There's actually the nice formula, and I'm going to show you how to do that, so things are a little simpler. Okay, so first off, remember, a quadratic function is a function in this form, ax squared. F of x is ax squared plus bx plus c, where a, b, and c are real numbers, and a is not 0. We said that the graph is what we call a parabola, and it looks like this. It's either a single valley or a single mountain, where the lowest point or the highest point is called the vertex. Now, we didn't say this, but it is symmetric. Okay, so these are there. You can imagine sort of an imaginary vertical line here, which is and the graph is supposed to be symmetric to that line. We call that the axis of symmetry, and it goes through the vertex. So we can use this symmetry to at least find the x-coordinate of this point. All we need is 2 points on the curve that have the same y-coordinate, because then they're just directly opposite each other. And so in this case, we have the points -2, 5, and the point 6, 5. They're on this. They are on this parabola. Okay. So the way we can do this is, well, the x-coordinate of this point is -2, and the x-coordinate of this point is 6. And we know that this point, whatever it is exactly halfway between -2 and 6. Okay, so we just need to find the midpoint between -2 and 6. And remember, to find the midpoint is very easy. We just add these two numbers together and then divide by 2. It's almost like taking their average. So we take -2 plus 6 over 2. That's 4. 4 divided by 2 is 2. So that's the x-coordinate of this vertex. So the x-coordinate of the vertex is 2. Okay. Now at this point, that's all we can do, because we're not really. We could do that. We could still find what a, b, and c are, but we'd have to do this with systems of equations and unknowns, because we don't know right now how to find the y-coordinate of the vertex. Okay, except with doing a lot of linear algebra. But what I'm going to do is if we know what the equation is, which is what we'll usually be doing, we can actually find out what this is. All right. So let me just go ahead and give you the idea behind this. So, okay. So let's say we have a parabola. We'll say it opens down. Okay. Let's say this is y equals ax squared plus bx plus c. All right. Now, in this case, now we know that there is the y-intercept is going to be c. Okay, because if we plug in x equals 0 here, we get c. But we can see that there's another point on the parabola that has the same y-coordinate at c. All right. Well, what would that be? Well, we can just set y equal to c. Okay. And then if we cancel c, subtract c from both sides, we get 0 equals ax squared plus bx. Okay. Now, can we solve for x? Well, we can if we factor out an x, and we'll get ax plus b. Okay, equals 0. So that means either x equals 0 or 0 equals ax plus b, in which case this means a minus ax equals b, and we divide both sides by a, which we can do because or negative a, because a is not 0, so we get x equals minus b over a. So here is our 0, and this point is going to be minus b over a. And then this point right here should be exactly halfway in between. And the midpoint of this would be 0 plus minus b over a all over 2. And if we simplify that, that's minus b over 2a, which is what the x-coordinate of the vertex is. Okay. Now, the good news is you do not have to do this for every problem. Okay, you can just use this formula that we just proved, that the x-coordinate of the vertex, in general, the x-coordinate of the vertex for y equals ax squared plus bx plus c is, in fact, minus b over 2a. Okay, and that can save you a lot of problems, okay, without having to graph this. So there are going to be some problems on the homework where they don't give you the equation, and they give you the graph, and here are these 2 points which are opposite each other. Then you basically just take the midpoint of them, and that'll give you the x-coordinate of the vertex. But for all other cases, you can go ahead and just use this formula if you know how to find your a, b, and c. That's to find the x-coordinate. To find the y-coordinate, you just find out whatever this number is, you can plug that back in here, and that will be your y value. So, for an example, in this case, x squared minus 8x plus 13, we see that a is 1, b is negative 8, and c is 13. So, minus b over 2a is going to be minus negative 8 over 2 times 1, and that's going to be positive 8 over 2, which is 4. So that's the x-coordinate of the vertex. And then to find the y value, we plug in 4, and we get 4 squared minus 8 times 4 plus 13. Okay, and then what is this? This is 16 minus 32 plus 13. This is negative 16 plus 13, that's negative 3. So we get that the vertex is 4, comma, negative 3. Okay, and then if we wanted to sketch the graph of that, we'd sketch the graph right here. Here's 4, here's negative 3, and it's right there, and we can, and then it opens up, and we can say that the y-intercept we know is 13, so it's going to be like, looks like this. Okay, we can't identify the x-intercepts exactly, without using a calculator right now, but we will see a way to do that. In some cases, we can do this with doing some algebra, but this is not one of those cases. All right. So why don't you go ahead and think about the next few examples and the next 2 examples, and we'll see you in the next video.